Questions 21 through 25 on the 2006 Grade 9 Pascal Math Contest. In each row of the table, the sum of the first two numbers equals the third number. Also, in each column of the table, the sum of the first two numbers equals the third number. What is the sum of the 9 numbers in the table? So, they've told you that this equals this and that equals that, pretty much, if you read the opening stem. So that means that m plus 8 plus 4 plus n is equal to 6. And that means that m plus n is equal to minus 6, right? 6 minus 12. And if you do that part, it's exactly the same. So it doesn't give you any different result. So now let's just jump to what they want, the sum of the 9 numbers. So let's add up all these 9 guys. So that's going to be, let's see here, m plus 4 plus m plus 4 plus 8 plus n plus 8 plus n plus m plus 8 plus 4 plus n plus 6. And if you add up all these guys, you get 3m plus 42 plus 3n. Factor out the 3, and that will give you m plus n plus 42. And the good news is that m plus n, we just figured out, was minus 6. So there you go. And that's going to be negative 18 plus 42, and that is equal to 24. So number 21, the answer is E. In the diagram, each of the 3 identical circles touch the other 2. The circumference of each circle is 36. What is the perimeter of the shaded region? I'm going to draw lines from the center of each circle to the center of the other circle, like that. And I hope you will come to the same conclusion that I did, that this circle, or this triangle rather, is equilateral. Why is it equilateral? Because this is the radius, this is the radius, that's the radius, that's the radius, and similarly, those two are radii. So all the sides are the same. So that is an equilateral triangle. And because it is so, the angles are 60 degrees, like that, each of these angles. So that means that if you need to calculate the perimeter, which is this red region that I'm drawing, you really just need to calculate this region right here and then multiply it by 3. Now that region from there to there is basically part of the circumference of the circle, right? But how much of the circumference? Well, that's where the angle comes in. It's 60 over 360. That's the fraction of the circumference. And the circumference, they tell you, is 36. So this is 1/6 over 36, which is just 6. So that little red region, that arc, is 6 in terms of its length. Well, the perimeter of that shaded region is 3 of those arcs, correct? So therefore, the perimeter of that shaded region would be 3 times 6, and that is 18. So number 22, the answer is A. Ben and Anna each have some CDs. If Anna gives 6 of her CDs to Ben, he would then have twice as many CDs as Anna. If instead Anna takes 6 CDs from Ben, then both would have the same number of CDs. What is the total number of CDs that Ben and Anna have? All right, so here's Ben, here's Anna. Let's figure out the mathematics of this. They tell you that if Anna gives 6 of her CDs to Ben, then Ben would be B plus 6. Essentially, Ben would have twice as many CDs as Anna. So that's the first mathematical equation. The second one is the next sentence. If Anna takes 6 CDs from Ben, so that's A plus 6, therefore that would be B minus 6, then both of them would have the same number of CDs, so this is equal. So this is the system of equations we have to solve. All right, well, any way you'd like to do this is fine. I'm just going to do this the following way. isolate for a, so that becomes b minus 12, and then substitute that over here. So this becomes b plus 6 is equal to 2a minus 12, like that. And then we got b plus 6, 2a. A is b minus 12. So this becomes b plus 6 is equal to 2b minus 24 minus 12. So b is therefore 6 plus 24 plus 12, and therefore b is equal to 42. And if b is 42, then that means a is 42 minus 42 minus 12, which is 30. And therefore Ben and Anna, the total number of CDs they have is a plus b. So that's 42 plus 30, and that is 72. So number 23, the answer is C. A bag contains 8 yellow marbles, 7 red marbles, and 5 black marbles. Without looking in the bag, Igor removes n marbles all at once. If he is to be sure that no matter which choice of n marbles he removes, there are at least 4 marbles of one color and at least 3 marbles of another color left in the bag, what is the maximum possible value of n? So we start off with 8 yellow, 7 red, and 5 black. So let's go through the answer choices and see what is the maximum. So we want the maximum, right? So let's start with the maximum of the answer choices, which is 10. Let's say n is equal to 10. And let's create a scenario for this that does not work. Okay? And if it does not work, we cross it off. First of all, what is it that we're trying to achieve? We want to have, as a final result, at least 4 of one color and at least 3 of another color. Okay, that is what we want. All right, let's see. If n is 10, if I take away 5 black, right? I'm looking at extreme case scenario. I'm trying to make this not work. Take away 5 black. Take all the black marbles away. And then I've got 5 left because I have to take away 10. And then the other 5, I'm going to take away the reds. If I do that, what do I have left? Well, I haven't done anything to the yellows, and I have only 2 R's left, and I have 0 black. Is this criteria fulfilled? Do I have 4 of at least one color and 3 of at least another color? The answer is no. I've got 8, but I've only got 2 of the red. So this criteria is not met, and therefore n cannot be 10. All right, let's keep going in the exact same way. Let's look at n equals 9. All right, extreme case scenario, right? But we can do this in several ways. But what I want to do is immediately try to make it not fulfill their criteria. So how many black marbles do I have to take away for it to drop down to 2? Because if it does, the criteria most likely will not be met. Well, to drop it down to 2, I've got to subtract 3 black marbles, correct? And now n is 9, so I've got to take away another 6. Let's say I take away 6 from the red. So what happens now in terms of a tally? Well, I've got 8 yellow, I've got only 1 R, and I've got only 2 black. Is this criteria satisfied? No. So that means n cannot be 9. Right? So we will continue exactly in this form. Let's try n equals 8. Okay, so same kind of thing. We're trying to make this not work. So immediately I'll take away 3 black. That would drop this down to 2. And then the remaining 5 I'll take away from the reds. If I do that, I've got 8 yellow, I've got 2 red, and I've got 2 black. Again, this criteria has not met. I'm trying to choose it in a way to not make it work. That means n is not 8. Let's try n equals 7. So again, I'll take away 3 black, and then n is 7, so the other 4 I'll take away from the red. So what's the end result? 8 yellow, and 3 red, and 2 black. Is this criteria met? It actually is now, because I've got at least 4 of one color, namely yellow, and at least 3 of another color, namely red. And for n equals 7, if you keep fiddling around with this, you will see that you're always going to be able to make the criteria work. So there you go. With a little bit of trial and error and casework for each of these answer choices, we get n equals 7 as the maximum possible value. So number 24, the answer is B. John writes a number with 2 187 digits on a blackboard, each digit being a 1 or a 2. Judith creates a new number from John's number by reading his number from left to right, and wherever she sees a 1, writing 112, and wherever she sees a 2, writing 111. For example, if John's number begins 2112, then Judith's number would begin 111, 112, 112, 111. After Judith finishes writing her number, she notices that the leftmost 2 187 digits in her number and in John's number are the same. How many times do 5 ones occur consecutively in John's number? So let's try to work with this. First and foremost, we've got John, and then we've got Judith, correct? Now we have to start figuring out what is John's number, and Judith's number we'll be able to figure out from what is John's number. So for example, if John's first digit is a 2 in the big long number, right? Judith will then write 1 1 1, correct? Entirely based on the question. When Judith sees a 1, she writes 1 1 2. When she sees a 2 in John's number, she writes 1 1 1. Okay? So 2 1 1 1, immediately this doesn't work. Why doesn't it work? Because this sentence right here, after Judith finishes writing her number, she notices that the leftmost 2 187 digits in her number and in John's number are the same. So when we write out all these numbers, we have to make them in a way so that they're always the same until we get to the 2 187 digits. Now, I'm not going to write out all 2 187 digits, but I'm going to try to see if there's a pattern here. So the only thing we figured out from this is that John's first number cannot be a 2. It must be a 1. Because if it's a 1, then Judith will then write 1 1 2. And so far, it matches. Okay? So if John's first number is 1, and then Judith writes this, then we then know then John's next number is also 1 and then 2. Why do we know that? Because the numbers always have to be the same for the first 2 187. You got it? Okay. I'm just going to do a few of these. So here we go. All right, so here we go. So the first one is a 1. And we go on from there. Remember, this is John, and these numbers are Judith. Okay? So just top row is John, and below that are Judith's numbers. Okay? So entirely based on what the question told me, if it's a 1, it becomes 1 1 2. And if it's a 2, it becomes 1 1 1 for Judith's way of writing it. All right? So I'm just going to keep going in this way, and I'm going to write out a lot of them, and then I'll come back and I'll explain what's going on. So here we go. For John, I've written out quite a few, and I've also written out quite a few numbers for Judith. And I'm not going to write out all 2 187, but I did write out 81 digits for John and 243 digits for Judith. And I did that to illustrate a certain pattern. Starting from the very beginning, his very first number, 1, and therefore Judith writes 1 1 2, right? That's the rule. And then Since Judith's first three numbers are 112, that must be John's first three numbers, because the first 2187 digits for both John and Judith must be the same. So John has a 1 for the second digit, so therefore Judith again writes 112. But his third digit is 2, so when she sees a 2, she writes 111. And this pattern just keeps on going, right? This system, this rule. And that's what I did. These top numbers are all John, all these guys are John, and the numbers below them, those are all Judith. Okay? Now, what do they want in our question? What is it that they want? They want you to figure out how many times do you have 5 consecutive ones? All right, well, let's figure it out based on what I wrote. 5 consecutive ones. Okay, I see this is one scenario. That's 1, 2. This is for John, right? Not for Judith. So I've got 3, 4. Any more? 5 here. 6. 6, and it looks like it's the start of another one, but we only have 6 full ones. Okay? It doesn't give me too much help, but it sort of gives me an idea. That means when I've written 81 digits for John, I get 6 times where you have 5 ones. Okay? Now let's look at Judith. Judith, I've written out 243 for her. So it should be more, right? It should give us a better idea. Okay, let's see here. 5 consecutive ones. There's 1, there's 2, and there's 3, there's 4, 5, 6, and then this one is 7. Do you see how that's 7? Because it's 111 here, but then it's 11 over there. See, I wrote it sort of like one on top of the other, but if this was all written out in one line, that would be 5 consecutive ones. So don't miss that. And then what are we up to here? 1, 2, 3, 4, 5, 6, 7. So this is 8, 9, 10, 11, 12, 13. Again, 14, okay? 15, 16, 17, 18, 19, and 20. Okay, that's a good number. So for 243 digits, you get 20 times that you have 5 ones in a row. All right, so at this point, what I did is I said, well, Judith's first 243 digits are the exact same as John's. Judith's first 2187 digits are going to be the same as John's. So if we have 20 in 247, then perhaps it will be the same in terms of a ratio for 2187. Well, let's see. 2187 divided by 243 is equal to what? Well, it's equal to 9. So for each 243 digit series, you'll get 11111 appearing 20 times. So that means since this is 9 times the length, it should be 20 times 9, which is 180. I hope you understood that. And then I went back to see the answer choices, and 180 is not one of the answer choices. So I thought, oh no, what do I do here? What did I do wrong? And the answer is I didn't do anything wrong. This is definitely part of it. You will get 180, but you'll get a few more. Why will you get a few more? Because eventually a couple more will pop up. Because eventually the key to understanding this question is that you get to a scenario like this, where you'll have ones at the very end. And when you match that with the next series, it joins to become one full 5-1 sequence. So that's a tough thing in this question. I really wish the answer was 180 so I could just circle it and move on with my life. But the fact that it's a few more than 180 is what makes this question difficult, and that's the part I have to explain now as to how many more than 180 are there. So to explain that, I've got to make a little bit of a table. So here we go. So I wanted to keep John and Judith's numbers, at least the first 81 digits for John and the first 243 digits for Judith in the screen. And then this table is going to be as follows. The first step, the length of each step, and then how many ones do we have in that step, how many twos do we have, and then what does that step end in terms of a number. Does it end in 1 or 2? And then how many of those 1, 1, 1, 1s do we have? What we're interested in. All right. So step number 1 is my very first one. Well, the length is just 1 digit, so that's 1. How many 1s do I have? Well, it was just 1, so I have 1, 1. How many 2s? Well, 0. It ends in a 1. And how many of these 5 1s do I have? Well, none yet. The next one is my 1, 1, 2, right here. Now, I can use John's or Judith's. I'll use Judith's because I've got so many more of hers. It's easier for me to look at that. So this is my step number 2 when I go to the next step, right? And this time, that 1, 1, 2 is step number 2, and the length is 3 now. Okay? 1, 1, 2 obviously is 3 digits. How many 1s are there in 1, 1, 2? Well, there's 2. How many 2s are there? Well, there's 1. And does it end in 1 or a 2? It ends in a 2. And how many of these 5 1s do I have? Well, 0 so far. Now the next step would involve 9. And it's these 9 right here. These guys right here. 1, 1, 2, 1, 1, 2, 1, 1, 1. Okay? So for those, that's the next step. It's a length of 9. How many 1s do I have? 1, 2, 3, 4, 5, 6, 7. How many 2s? 2. It ends in a 1. And how many of those 5 1 strings do I have? Well, none. It starts off with 1, like it's part of 1 is there, but there's no full 5 1s in a row. So the answer is 0. But in brackets, I'll put like a half just to show that a part of it is beginning. All right, let's keep going here. Fourth step would involve 27. 27 digits, so it's basically all these guys. These 27 numbers. And that would mean the number of 1s, oh boy, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And the number of 2s, 1, 2, 3, 4, 5, 6, 7. It ends in a 2, right? Because this is the last digit, it's a 2. And how many of these, how many of these 5 1s do we have? We've got 2 of them. We got 1 here and we got 1 there. So finally, we have a few full ones. And then you just continue like this. But you say, well, okay, I understand that you're multiplying by 3 every time. So when you get to 81, it's going to be this whole, all of these. That's 81. But you really expect me to sit there and count all the 1s? And the good news is you don't have to. Here's a trick. The number of 2s is going to be the same as the number of 1s from the previous step. Let me repeat that. The number of 2s will be the same as the number of 1s from the previous step. Why? Because whenever you had a 1, you remember in our system, whenever Judith saw a 1, she made a 1, 1, 2 in her step. So every time there's a 1, in the next step, there's going to be the same number of 2s. So that means that the number of 2s at each step equals the number of 1s from the previous step. So using that very important piece of information, we can fill this in a little bit more quickly. Here, it's going to be 20 because the number of 2's at each step equals the number of 1's at the previous step. And therefore, since the length is 81 and 20 of them are 2's, the other 61 must be 1's. So that's just a subtraction. This one, have I got 81 in a row? Yeah, I got 81 in a row. So the last one is right here. It's a 1. Okay, and then how many of these 5 1's do we have in a row here? Let's see. 1, 2, 3, 4, 5, 6. 6 and a little bit of the 7th. So I'll put 6, and then I'll put sort of like 6.5 in brackets just to show that there's one that's about to start right here. You notice this one here? Okay, 7th step, again, multiplying by 3, 243. The good news is we do have the full 243 written out, and that's all of these guys. This one, and this one, all of Judith's basically. So the bottom rows. And that one, okay, I'm certainly not going to expect you to count the number of 2's, but you don't have to. It's the number of 1's from the previous row. So there you go. And this is just a subtraction now, 243 minus 61, which is 182. Okay? And then this ends, the very last one was a 2. And then how many do we have? Okay, this is the big one here. So we got 1, 2, 3, 4, 5, 6, 7, right? 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And remember, we had actually figured that out earlier, that it was 20. So put that in there. So this is 20, a full 20. Okay, now bad news is that for the next step, I actually don't have it all written out, and I'm not going to write out 729 of these. But we can use the system to figure out what these numbers are. Well, the number of 2's is the same as the number of 1's in the previous row, so this is 182. 729 minus 182, it's a subtraction question to get the number of 1's. This ends, well, by this point, it's 1, 2, 1, 2, 1, 2. So I'm pretty confident this is a 1. But this is the question right here. Well, it's 3 times the number of digits, right? This is 243, this is 729. So you would think it's 3 times 20. Okay, but here's the thing. The answer is 60. But because it ends in a 1 right here. That means when you get to the final, it's going to look something like this right there. It ends in a 1, so it's going to be part of the next 1, 1, 1, 1, 1, 1. So I'm going to put a little half like that. Does that make sense? I hope so. So, because that's the heart of understanding this question. That's how we're going to end up with more than 180. Remember, I got 180 before, but that's not one of the answer choices. All right. Hopefully the last one will put it all together. The last step is when you get to the full 2187. Remember, the number of 2's is the same as the number of 1's in the previous row. And then to get the number of 1's, you just subtract 2187 minus 547 is 1640. This is going to end in a 2. And this is the heart of our question in terms of our answer. What is that answer? Well, I previously got 180. Okay, this is where you get the final answer. So, here we go. Pay close attention now. For a string of 729, right? You have 60 of these 1, 1, 1, 1, 1, 5 1's in a row. For the next 729, again, you'll have 60. And notice what I'm doing. I'm putting a little bit of a half in brackets. And then for the next 729, you'll have 60 like that. Okay? 60 plus 60 plus 60 is 180. But there's these halves. And what does those halves represent? Do you remember? In my, diagram, they represent sort of 1, 1, 1 at the very end. And that will join with a 1, 1 at the beginning of the next string to create a 5 consecutive 1 sequence. So each of these will give you a 1, 1, 1, and then it will join with the 1, 1 from the next one. Does that make sense? And then similarly, from the next 729, it will be 1, 1, 1. It will join with the first 2 ones in the next sequence. And that's how you end up getting 2 more. So the final answer is 180 plus 2, which is 182. And that is the answer to this question. So I will admit this is difficult because I got 180 and then I couldn't figure out for the life of me how you could get more than 180. And I had to go through this entire system in order to get the final answer of 182. So it's difficult, but if you have some sort of a system, you should be able to figure this out. So number 25, the answer is A.